There's a sheet, attendance sheet going around, so make sure that you sign it. Okay, so share my screen. I already see two messages in the chat. Let me see what they're saying. Oh, okay. All right, so good morning, first of all. And I promised you that I would bring copies of the assignments. Unfortunately, I was not able to do that because of some issues with my desktop in my office that IT folks are currently working on. So that kind of make things a bit more challenging for me, but I'm going to try to work through it. So assignment for chapter 2, I'm going to bring up here. Let me just download it from here. But before we get to the assignments, as I said before, the standing arrangement is that you should be watching the videos for at least for this week, up to today, chapters 2 and 3. So my first question is, are there any questions concerning what was covered in the videos? Yes, ma'am.
There was one problem. I think it was
Let me see if I can bring up the PowerPoint for, is it chapter 2 or 3?
It was chapter 2, I think, problem solving.
Let me see if I can bring that up. Chapter 2 PowerPoints.
And it was under, I think, the problem solving section.
Oh, lecture notes, that's great. By the way, just to remind you, I'm recording, this class as well. So I'll be posting it up later on today in YouTube. Well, not in YouTube, I'm sorry, in Canvas as a YouTube video. So if you want to rewatch it, and this is going to be the standard practice. I don't know if I told you this before, but pretty much that's what I'll be doing for all my lectures. So even if you miss a class, you can still catch up on the material by watching the videos. So okay, this thing is taking its time. Okay, so let me do this. Okay, so can you let me know where?
So the problem was an atom of hydrogen weighs 1.674 times 10 to the negative 24th degree grams. How many ounces does the atom weigh? And so when working out the problem, I got a different answer. And I'm just curious. So I think when
well, let me see if I can find the problem first. I think I have an idea where it might be located. Is it? No, not that one. Oh, this one, right?
Yes.
Okay, all right.
So in the problem, I just want to make sure, so you're supposed to multiply first by the number on top of the fraction, and then you divide by the bottom.
It doesn't matter the order. You can divide by the bottom first or
And then-
multiply by the
And
top.
then multiply, so the answer that I got when I multiplied by the top and then divided by the bottom was 3.7 times 10 to the negative 27th. Or sorry, that was the answer that you got. I got 5.9049 times 10 to the negative 24th.
Okay, so let me do it the way that you described. So you're saying you're multiplying the 1.674 times 10 to the minus 24 by the 16.
Yep, and
Okay, let
then,
me do that first. So 1.674 times 10 to the minus 24 times 16. And I got 2.6784 times 10 to the minus 23. That's what I got. And then if I were to divide that by the 453.99 divided by 453.99, I got 5.896892. But we have to round off
so
to 4 sig figs.
I think in the recording, the answer that you provided was 3.7 times 10 to the negative 27.
For the final answer?
Yes,
Okay, that would be incorrect. I'll have to go and check on that one.
okay,
But the final answer would be what you see here, 5.900 times 10 to the minus 26.
just wanted to.
Yeah. I'll definitely go and check it out. All right, any other questions? Any other questions concerning the video lectures? If not, then what I'm gonna do is go to the assignments. Again, unfortunately, I don't have copies here to share with you. So I'm just going to put it, okay, what's going on here? I'm just going to put it on the board, on the screen. Okay. So let me go. Okay, so we're going to start with chapter 2, assignments. And the first question has to do with converting numbers given in a normal standard notation to scientific notation. So just to briefly recap what was covered in the videos, when you're writing a number in scientific notation, there are two parts to expressing it that way. Let me do this, see if this works. Okay, so for example, there's a number that you're going to meet later on, which is known as Avogadro's number, which is 6.02 times 10 to the 23, right? It represents the number of atoms, particles, whatever, in 1 mole. The important thing I want to stress here is that I was saying that there are two parts to a number expressed in scientific notation. You have the coefficient, this is called the coefficient, and you have this number here, which is the exponent, right? So basically, to represent or express a number in scientific notation, you have to write down first the coefficient and then the exponent, right? Oh, well, I should say first the coefficient, then 10 raised to the exponent, right? Now, the coefficient, as far as standard notation is concerned, must be written in a special way, right? It must have a digit, right? A non-zero digit, I should add, then a decimal point, and then if there are any other digits following, you would include those, right? So like in this case here, the first digit here is 6, and then you have the decimal point, and then you have other digits. In this case, 02 would be the following digits, right? So this is what we call, or the way this is expressed or written is called the standard, it's called the scientific notation. Now here, we're given the numbers here that are not in scientific notation. So the question is, how do we get from here to it looking something like this? And the answer is that you have to make sure that you move the decimal point to a position in a number where it is sitting just to the right of the first non-zero digit, right? So I'm going to show you how to do that. And I've showed you actually how to do that in the videos, but I'm just going to work the two first examples so that you see how that works. So here we're given 3,400, right? Now, the decimal point is not shown explicitly here, but we understand that there's a decimal point here, right? So the decimal point would be here, and therefore what we have to do is make sure that the decimal point is moved from this position to where the comma is. So that means that we have to move the decimal point 1, 2, 3 places to the left. So when we do that, you're going to end up with 3.4, right? And then we have to multiply by 10 raised to the exponent. So basically what we have determined so far is a coefficient. So the question is, what would be the exponent? And the exponent in this case would represent the number of places that the decimal point would have to jump in order to get to the right, exact right, or immediate right of number 3. Here, the digit 3. So therefore, as we said before, the decimal point jumps 1, 2, 3 positions. So therefore, the exponent here would be 3. So the answer here would be 3.4 times 10 to the 3. All right, and that's basically how you get from 3,400 to the number expressed in scientific notation, which is 3.4 times 10 to the 3. Now, for the next one, right? Well, firstly, any questions about the first one we just looked at? Any question? Any question? Okay, now for the next one, things are a bit different because this time we're given this number where, in order to get the correct, I keep saying exponent, the correct coefficient, we'd have to move the decimal point 1, 2, 3, 4, 5, right? So the question is, well, we know what the coefficient is. It's going to be 2.3 multiplied by 10 to the, in this case now, because we have to move the decimal point 5 places to the right, the exponent will be negative 5, right? So basically, if you're moving the decimal point to the left, then the exponent is going to be positive, but if you move it to the right, it's going to be negative, all right? So therefore, the answer in this case for B would be 2.3 times 10 to the minus 5, all right? Okay, any questions about this one? Any questions? Any questions? Okay, so let's look at this one. Let me hear what you have to say about this one. How would we convert that to scientific notation? And you guys out there in Zoom, you guys can contribute as well. Feel free to speak up. Yes, ma'am.
You move the decimal place to behind the first one.
Okay, so 1, 2, 3, 4, 5, right? Okay, so what's going to be the coefficient in this case? 1.01 multiplied by 10 to the? Exactly, 10 to the 5. That's it. All right? Okay, what about D? How would you convert 0.010 to scientific notation? Which direction would you shift the decimal point? To the right. To the right, exactly. And how many places would we, oh, somebody's saying something online. Okay, this person just agreed with us. All right, so to the right. So basically we're gonna move decimal point 1, 2, right? So what would be the coefficient? 1.0 multiplied by 10 to the
second.
You sure about that?
Negative 10 to the second.
Exactly, minus 2. Remember, we're moving the decimal point to the right, so therefore the sign is going to be negative, all right? Okay, so what I'm going to let you guys do now is work on E through, oh, this is a typo, this should be F, all right? Work on E through F, all right? Right now, if you have any problems, speak up, all right? I want you to complete that first before we move on to the other part, all right? In the meantime, did everybody sign the sheet? Attendance sheet? Okay. I'm sorry? I'll have to look and see.
Do you need?
Or, yeah. Okay, somebody's saying something over there in Zoom. Oh, I'm sorry. For you guys out there in Zoom, you can access it. I apologize for that. Let me go here. I think I published it already, but maybe I didn't. This. Oh yes, it's published. Oh no, that's hold on. Oh, that's the PowerPoint. Let me assignments. Okay, so for you guys out there in Zoom, it's published, right? You just go to assignment spring 22, and then you should be able to download those assignments. Okay, somebody's saying something again. Oh, okay. And for you guys out there in Zoom, somebody's asking about signing in for attendance. You don't have to because Zoom already recorded your presence. So I can just look at that information and record your presence. So you don't need to sign anything. Anybody else need to sign the attendance sheet? Okay, everyone decided? Okay, are we finished with this section? Okay, so let me hear the answers for the rest of this. Let me turn this on. Okay, so what's the answer for E? 4.501 times 10 to the what? Very good. What about F? 1 times 10 to the 6. What about G? I'm sorry, this should be F. G, this should be H. Okay, G, I'm sorry.
6.6.
6.71 times
10 to negative
10 to the minus what? 3? Okay, and then finally, H. 4.50? Exactly. Okay, so that's basically how that is done. All right. So if you understood this, then you should be able to do the reverse, which is what the other part, let me clear this first, which is what the other part is all about. In the other part, they gave you the scientific notation for the different numbers, but this time they're asking for you to convert that to the standard notation, which is the reverse of what we just did. So let me hear what you have to say about I. What would be your answer? Scientific. Okay, so what would be your answer in this case? To what? 23,000, yes, that would be correct. What about J?
0.00176.
0.00176. All right. So I'm going to leave the rest of you to do right now. Again, if you have any problems, let me know. All right. And I'll be right back. Are we finished? All right, so let's hear your answers to the rest of these, starting with K. Oops, hold on, wait a minute. This thing is. Okay, what's going on with this? Okay, 0.000.
6 zeros.
I'm sorry?
6 zeros.
6 zeros? And then,
1901.
okay, yeah, that sounds about right. Okay, what about L? I mean, yes, L.
0.865.
0.865. And somebody's chiming in from Zoom. Oh, again, this person is agreeing with us. Okay, what about M?
9,110.
9,110. What about N? Oh yeah, 54. Actually, it's 54.0, but I'll explain why the zero is added in this case later on. What about O? 1.76, and then P?
0.00074.
0.000. One more zero, right?
4 zeros.
Yeah, and then 74. Okay, very good. All right. So far, so good. So let me clear this. Scroll down to the next question, which is, okay, determine the number of significant figures in each of the following measured quantities, right? So again, this was covered in the videos, but just to briefly describe how do you determine the number of sig figs? If you're given in a question a value which represents some measurement, it could be mass, it could be volume, whatever, right? And I'm just going to go through the rules briefly as I can recall them. The first rule is the easiest. All non-zero digits are significant, right? All digits from 1 to 9 are significant. I don't remember the order of the rules in the video, but I know one rule says that all preceding zeros, in other words, zeros coming before the first non-zero digit, will not be significant, right? So if you're given a number like if you're given a number like 0.01025, then these zeros here would not be significant, right? All zeros that comes before the first non-zero digit will not be significant, right? And all the other rules, by the way, have to do with zeros in particular situations, all right? I'm going to add another zero here just to make things, just to give an example. Let me just erase that. Okay, the other rule, as I recall, has to do with zeros that are sandwiched between non-zero digits, right? So those zeros will be significant, right? So if you have two non-zero digits on either side of a zero, right, then the zero would be significant. So for example, this zero here would be significant because it is sandwiched between a 1 and a 2 on either side, right? So this zero would be significant, right? The other rule has to do with trailing zeros, where there's a decimal point. So if you have a decimal point in a number and you have a zero at the end of that number, then that zero would be significant as well, right? Is that it? I think that's it as far as the rules are concerned. Oh, another rule here, if you're given a number where there's no decimal point, but you have zeros at the end, like 0.0, I'm sorry, like 3,000, right? No decimal points, right? Indicated, which means that these zeros are not significant, all right? And I think that covers all the rules concerning how you determine the significance of zeros or any digit in a measured value, right? And what I described here applies to numbers obtained by measurement or directly or indirectly. In other words, you did some calculations using measured numbers and you get a result, right? So with that said, let's see if we can answer question number 2. So let me clear this here and let's deal with the first one. So the question is asking for you to determine the number of significant digits, right? So in the case of the first one, how many significant digits do you think is represented in that number? Okay. No. 3, exactly. And the reason why is because, as I said before, any zeros that come before any first non-zero digit will not be significant, right? So here we have 3 zeros, actually 4, but excluding one outside here on it before the decimal point. We have 3 zeros here. Those zeros will not be significant. So therefore, the number of significant digits represented here would be 3. Okay, what about B? 3. And let me just say something about B. As you can see, it's written in scientific notation, right? When you're trying to determine the number of significant digits for a number written in scientific notation, we only pay attention to the coefficient, right? We do not look at the exponent, right? So as she correctly said, this would be 3 significant digits because we have 3.5 and we have a 0 at the end of this number. That 0 will be significant because of the presence of the decimal point. So the answer here would be 3. Okay, what about C? It would be 6, exactly. Because for several reasons, apart from the non-zero digits being present, you have this 0 here and this 0, which is sandwiched between non-zero digits. And we have this 0 at the end where there's a decimal point. So therefore, the total number of significant digits, here would be 6. And then we get to D. How many significant digits are represented here? 4, exactly, because this 0 here is sandwiched between non-zero digits, all right? Okay, so that's pretty much it for number 2. Any questions? Any questions about number 2? All right, so let me clear this. Let's go down. And now we're going to get into a situation where we do some mathematical operations. And I'm quite sure I stressed this in the video or videos, that when it comes to mathematical operations, especially when it comes to measured numbers, you have to make sure that you follow some rules so as to get the final answer represented to the correct level of precision. And that usually means, or that will mean, it either will have the correct number of significant figures in the final answer or the correct numbers of decimal places, right? So the rules are, and let me just briefly describe the rules. The first rule has to do with multiplication and division, right? And basically what that rule says is that if you're multiplying and or dividing numbers, you round off your final answer to the lowest number of significant digits represented in the calculation. So I'm just going to give a simple example here. Let's say you're given 2.4 multiplied by 3.71, right? And let's say these are, grams, just for argument's sake, right? So basically, if you do the calculation, let me do this now on my calculator, 2.4 times 3.71. Okay, so what I got on my calculator display is 8.904, right? Grams squared. You have to square this because it's grams multiplied by grams, all right? Now, what you need to do is round this off to the correct number of sig figs in this case because you're multiplying, right? How do we do that? We look at these two numbers and we look at the number of significant figures represented in each of these two numbers. So this one has 2 significant figures and this one has 3 significant figures, right? And therefore, what you need to do in sig figs, what you need to do in order to round this off correctly is that you round this off according to the one that has the lowest or lower, in this case, number of significant digits, which would be 2 significant digits here. So that means that you need to round this off to 8.9 grams squared. And that's basically how you do that. And you would do the same thing if you were dividing. All right, you do the same thing if you're dividing. You round off according to the lowest number of significant digits involved in the calculation. All right. So when it comes to, so that's, by the way, multiplication and division. The rules are a bit different when it comes to addition and subtraction. So let me use the same 2 numbers. So this time I'm going to add 2.4 grams to 3.71 grams, right? Now, in this particular case, you have to, according to the rules, when you're adding and or subtracting numbers, you round off your answer to the lowest number of decimal places, right? So basically, let me do this on my calculator here. If I add 2.4 to 3.71, on my calculator, I got 6.11 grams when I add them, right? So basically what I need to do is round this off to the level of one of the numbers involved having the lowest number of decimal places, which would be this one. This one has 1 decimal place, whereas this one has 2 decimal places, right? So therefore, that means that I have to round this off to 1 decimal place. So therefore, this becomes 6.1 grams, right? And then I would do the same thing if I were to do subtraction. I would have to round off the final answer to the lowest number of decimal places. So just to recap, when you're multiplying and or dividing, you round off your final answer to the lowest number of significant figures of the numbers involved in the whole process of calculation. If you're adding and or subtracting, then you round off your answer to the lowest number of decimal places, all right? Okay, so with that said, let's look at, let me clear this here, number 3A. So this is what you're given. The question is asking for you to perform the calculations and round off the answer to the correct or proper number of significant figures, all right? So of course, you'd have to use your calculator to do this addition. So it's 1.25 plus 6.2 minus 8.01 plus 0.889. And according to my calculator, and please correct me if I'm wrong, if you got something else, but I got 0.329, right? And the units here would be meters because you're adding meters units right across the board here, right? However, this would not be the final answer. You'd have to round this off to the correct number of
0.3.
I'm sorry?
0.3.
Well, yes, you kind of jumped the gun. Yeah, but yeah, the answer is 0.3, but the answer I was looking for is what? Correct number of what? No, not sig figs. Remember the rules I said. You round off, when it comes to addition and subtraction, round off to the lowest number of decimal places, right? So in this case here, the lowest number of decimal places would be this one here, which would be 1. So that means, as he said correctly, the final answer is going to be 0.3 meters. All right? So that's what you do in that particular case. Okay, any questions about that? Any questions? Okay, let's look at this question now. This one is a bit more complicated because you have a couple of mathematical operations for which the rules are different for one compared to the other, right? You're given here 78.8680 grams divided by the sum of this total below here, which is 23.5 plus 10 mils, all right? So the question is, what's the final answer? Again, corrected or written to the correct number of significant digits, right? So what I would do in this particular case is work out what's within the parentheses first, all right? So if you take 23.5 plus 10, you're going to get 33.5, right? However, we need to, when you're adding, as we just said in regards to the previous problem, when we're adding and or subtracting, we round off our answer to the lowest number of decimal places, right? So therefore, this would have to be rounded off to what? Because you have 0 decimal places here, and you have 1 decimal places here, 1 decimal place. So what would be this rounded off to? 34, not 33, right? So this would be 34 mils. So now that we have done that, now we have to divide all of this here, the 78.8680, by the 34. So let me do that here. 78.8680 divided by 34. And according to my calculations, I got a long string of numbers, 2.319647059, right? However, now because we are dividing, right? What did we say about dividing in terms of rounding off? What's the rule? You round off according to the lowest number of? Okay, so in this case here, we have 1, 2, 3, 4, 5, 6 significant figures. Here we have 2, so that means what?
How did you get 33.5 from the 23.5?
Because we had 23.5 plus 10, that gives you.
Oh, sorry.
Yeah, right. Okay, so we have, how many sig figs I said here? 6, right? And here we have 2 sig figs, right? So that means, what do we do with this? We have to round it off to what? 2 sig figs, exactly. So when we round this off to 2 sig figs, what do we get? 2.3, and the units would be grams per mil, because we had grams divided by mils, so therefore that would be the final answer, 2.3 grams per mil. All right? And this is basically what you need to do in all your calculations in this class, right? You have to make sure that when you're dividing or multiplying, or let me repeat that or re-say that. When you're dividing and or multiplying, you round off according to the lowest number of decimal places. When you're adding and or subtracting, you round off according to the lowest number of significant figures. And if you're doing a combination, you know, like what we did here, then you have to do it piecemeal. In other words, like in this case here, I worked out what was in the parentheses first, and then I round off. In this case, you round off to the lowest number of decimal places, and then when you do division, you round off according to the lowest number of sig figs to get the final answer. Okay, any questions about number 3? Any questions? All right, so let me clear this. And number 4 is asking for you to round off the following, each of these to 3 significant figures. All right, so let's start off with A. So when you round this off to 3 sig figs, what will you get in your answer? 135. Don't forget the units, meters. What about B? 80. 80.0, that's correct. Grams. What about C?
126.
Nope. Nope. You're right about 126. But there's something else you need to add. A 0, exactly. Because when it comes to on the left side of the decimal point, if you need to drop a digit, you have to replace it with a 0, and then you have to increase the other digit in this case, because it's 5 or greater, by 1. So therefore, the final answer will be 1,260 mils. All right? What about D?
$1.20.
1.20 times 10 to the minus 5 millimeters. And that's basically how you do that. All right? Any questions? Any questions? All right, let me clear this and move on to the next question, which is, okay, so now we're going to get into conversions, right? Converting from one unit to another, right? So you're going to see some of what we just discussed earlier come into play when it comes to doing questions like these, all right? Okay, so the question says you're to convert the following quantities. And the first one, you're given 565,900 seconds into days, right? So basically, we need to identify the relationship between seconds and days. Now, you may not know the relationship straight off from the top of your head, but I'm quite sure you know the relationship between seconds and minutes, minutes to hours, hours to days, right? So we know, for example, that there are 60 seconds is equal to 1 minute. We also know that 60 minutes is equal to 1 hour, and we know that 24 hours is equal to 1 day, all right? Now, of course, in order to solve this problem, we start off with what we're given, which is the 565,900 seconds, right? And what we have to do is basically, and we covered this in the videos, we have to use what we call conversion factors, right? Each conversion factor would represent the relationship between, for example, the units of seconds and minutes, or the units of hours and minutes, and so on and so forth, right? So basically, what we need to do now is to multiply this number that we're starting off with, since it's given in seconds, and we know the relationship between the seconds and minutes, we have to convert from seconds to minutes. So how do we do that in this conversion factor? Well, because we have the second unit here, this 60 seconds would go down here, right? Because you want the second units to cancel out. And up top, you're going to put 1 minute, right? So what we have done so far is to convert from seconds to minutes. The next step is to convert from minutes to hours. And we have the relationship here. And that also would be represented by a conversion factor that we need to write here. So the question now becomes, how do we represent the conversion or represent this using this conversion factor? In this case, we want to get rid of the minute units to convert to hours. So therefore, the 60 minutes would go down here, right? And the 1 hour would go up top as a numerator, right? So what we have done so far is to convert from minutes to hours. And remember now, we're trying to go from seconds to days. So the next conversion factor would represent the relationship between the hour unit and the day unit. 24 hours is in 1 day, all right? So we're going to put 24 hours here and 1 day here, and that's it, right? Because the hour unit will cancel out here. So whatever we get here, the final answer is going to be in days. So all we have to do now is the number crunching. So I'm going to put 565, 900, divided by 60, divided by 60, divided by 24. All right? And according to my calculation, now here we have to round off to 4 sig figs because we have 4 sig figs here, right? So when I do that, the answer I got is 6.550 days. All right? And that's basically how that is done. Now, let me just say this. You might be wondering, I think I covered this in the videos, but you might be wondering, why don't I take into account these numbers when rounding off, right? And the answer is that there's a difference between what is known as measured values and exact values. And I covered those two differences in the videos. But just to briefly describe the difference between the two, measured values, as the name suggests, are numbers obtained by measurement, right? So if you weigh something or you measure something using a ruler or whatever, that's a measured number. Whatever number you end up with, that's a measured number, right? The thing about measured numbers is that they have a finite number of significant digits, all right? So basically, if you, like for example, the balances that we use in the lab up here, they weigh everything to 3 decimal places, right? So if I put something on the balance and I get 6.523, right? Then basically that would be 4 significant digits, right? And that is true for every measured value. They have a finite number of significant digits. Now, in the case of exact numbers, and let me write this down here, exact numbers have an infinite number of sig figs, right? And I talked about 2 types of exact numbers that you will encounter, right, in this course. One of them is numbers obtained by definition, right? So for example, the relationship between the second unit and the minute unit, that's an exact relationship because it's a defined relationship between seconds and minutes, or between minutes and hours, or hours and days, and so on. Those are exact numbers, right? Because those numbers are obtained by definition. Now, another type of exact numbers are numbers obtained by counting, all right? So for example, if I had a class of, let's say, 25 students, then that number 25 is an exact number, right? It's not measured. I did not use an instrument to measure that number. I simply do a head count, and therefore that's a number, right? Such numbers have an infinite number of significant digits, right? So the reason why I'm stressing that is because here we have 4 sig figs, and all these numbers here have all these numbers here have an infinite number of sig figs, right? And as we said before, when you're multiplying and or dividing numbers, you round off your answer to the lowest number of sig figs, right? So if you're multiplying a number which has 4 sig figs by numbers which have an infinite number of sig figs, then the final answer must be rounded off to 4, right? And that's the reason why we round off to 4 sig figs in this particular case, all right? Okay, so that's basically that for number 5A. Any questions before we move on? Any questions? Any questions? Okay, so let's look at number 5B. Let me clear this first. And let me hear what you have to say about this, based on what we have covered in the first question. All right, how would you tackle this problem?
Conversion factors.
Okay, so, all right, so what conversion?
1 year.
1 year,
65 days.
365 days, assuming it's not a leap year. And then what else?
1 day.
1 day equals
24 hours.
24 hours. What else?
1 hour and 60 minutes.
Okay, so these are the relationships that you're going to use. All right, so we're going to start off with the 17 years, and we're going to multiply that by what? The first conversion factor. I'm sorry?
365.
365, whoops, 365 days over 1 year. Okay, so that the year unit cancel out, right? Then the next conversion factor is what? Okay, so 24 hours above, and what goes down here as a denominator? 1 day. And then what's the next conversion factor? 60
Hours. No, 60
minutes
minutes.
above and 1 hour below. So the days unit cancel out, the hour units cancel out. So the only unit remaining would be the minute unit. Let me just erase this here. Okay, so let's do the number crunching. 17 times 3, oops, I did something wrong. 17 times 365 times 24 times 60. And I got 8.935 200 minutes. Is that the final answer? No, you have to round it, right? So to what extent do we round this number here? Oh, sorry, by the way, I made a mistake. This should not be a decimal point here. Okay, so what would be the final answer when you round off appropriately? How many sig figs do you have here? 2. So you have to round this answer off to 2 because these are all exact relationships, right? So what would be in the coefficient firstly? I'm sorry? 8.9, right? Multiply by 10 to the what?
6 pounds.
Times 6, 10 to the 6. Minutes to the minus 1. Or if you prefer, you can simply write it as 89 with 5 zeros. Minutes, right? Same thing. All right? Okay, any questions about this one? Any questions? Questions? No questions? Okay, so let's clear this. Move down to the next one, which is 43 miles into feet. Now, for this one, I would expect you to know the relationship between feet and miles directly or indirectly. And that's the reason why, as I told you before, I've provided tables which you'll have access to during your test, right? And the table contains some of these conversion factors. So let me scroll down to the tables folder. And this is the document that you're gonna download and open up. All right, so let me scroll down to where the conversion relationships are. Okay, so that's basically, this is the table here that we're going to use. So the question is asking for the relation to go from miles to feet, right? So we will go to this part right here, and we have a direct relationship right here. 1 mile is equal to 5,280 feet, right? So 1 mile is equal to 5,280 feet. 80 feet. All right. So how do we set this up? Here. Well, let me start you guys off. 43 miles. What do we multiply that by? What goes up top and what goes below? 5,280 feet and 1 mile down here. All right. So let's see here. 43 times 5,280. And how many sig figs do we need to round this off to? 2, right? So I got a long string of numbers. I'm not going to write it down. I'm just going to write down the final answer, which would be 1, 2, 3, 4, 5. So it's going to be 2.3 times 10 to the 5 feet. All right? And that's how you do that. All right? Any questions about this? Any questions? Any questions? All right. Let me clear this. Oh, by the way, I'm forgetting about you guys out there in Zoom. Any questions out there? Okay, I'll take your non-response, meaning that you understand what I'm doing perfectly. So let's look at D. Now, in the case of D, D is a bit different from the others because in the case of D, you're going from pounds, which is a non-metric unit, to kilograms, which is a metric unit. And there's a slight difference in terms of how we approach this, which I'm going to show you right now. So again, we would have to refer to the tables to look at the relationship between pounds and kilograms, and that's given right here. 1 pound is equal to 453.59. Let me write this down here. 1 pound is equal to 453.59 grams. All right. All right. So let's see what we can do with this. So the question says you're starting off with 165 pounds. 165 pounds, and we want to convert it to kilograms. So my question to you is, what would be the conversion factor? What would be in the numerator and what would be in the denominator? Okay, I'm sorry? No. The 453.59 would be in the, 59 would be in the numerator, and 1 pound would be down there in the denominator. So in this case here, it's 165 multiplied by 453.59, and I got the answer here, 74842.35 grams. All right. Now here's the thing, and this is another thing that you have to keep in mind when it comes to doing these calculations. Here we have a metric unit, and here we have a non-metric unit. When you're going from metric to non-metric or vice versa, you have to take these numbers into account in terms of sig figs, all right? Not so much the 1 pound, but the other digit, the other number here, right? That is true whenever you're going from metric to non-metric or vice versa, all right? With one exception, and that one exception is the relationship between the inch unit and the centimeter unit, because this is a defined unit. So this is by definition, right? So therefore, these numbers would be exact and have an infinite number of significant digits. In the case of other relationships between metric and non-metric, you have to take into account the number of significant digits because it's not, in those cases, defined, all right? Now, in this case here, we have 3 sig figs and we have more than 3 sig figs. We have, in fact, 5 sig figs. So that means we need to round this off to 3 sig figs. So if I were to round this off to 3 sig figs, it's going to be what? 7, 4, 7, 4, 8, and then you're going to have 2 more zeros, and then grams. Or if you want to express it in scientific notation, that would be 7.48 times 10 to the 4 grams. Same thing, all right? Sometimes it's more convenient to write it in scientific notation. Okay, and that's basically how you do that, all right? Now, what I'm going to do is I'm going to leave the rest of this question for you to do on your own, because I want to jump to the next one, unless there are any questions about this one. Any questions? Yes, sir.
It says to round into kilograms. Right?
Oh, thank you. So we need another conversion factor. Thank you very much. I don't know, I kept saying grams or seeing grams. So very good. So let me erase this here. And ask you, what would you do next? Whoops. Yeah, almost erase this here.
I put 1,000 grams and then 1 kilogram.
You're absolutely right. So you multiply by another conversion factor, and where you're converting, as he correctly said, there are 1,000 grams in 1 kilogram. All right. So basically, what will go below here?
1 kg.
Below? You sure about that?
1,000.
1,000 grams, exactly. And up here, you're going to have 1 kilogram. So that will go with that. So let's do this calculation, which should be correct now. So basically, it's 165 times 453.59, and then divide by 1,000. And I got 74.8 when rounded off to 3 sig figs. Kilograms. And that's how you do that. All right? Okay, any questions about this? Any questions? All right, so like I said, I'm going to leave the rest of that question for you to do. If you have any problems while doing this, doing those questions, feel free to contact me via email so that we can link up on Zoom. Okay, so I'm going to go down to these. These should be relatively easy, right? You're converting from one unit to another, all in the metric system. So let me hear what you have to say for the first one. How would you convert from 25 milligrams to grams? So we're going to start off with 25 milligrams, and we're going to multiply that by what? What goes below and what goes above? I'm sorry?
Milligrams on the bottom.
Okay, how many milligrams is in 1 gram? 1,000 milligrams is in 1 gram, and that's it. And the answer will become 0.025, and that's it. And if you can do that, you should be able to do the rest of number 6. All right? So I'm going to skip that as well, or skip those as well. Let me do this. Go down. Okay, now let's look at this one. This one has to do with the concept of density, which I discussed as well in the videos. So firstly, just to remind you, the definition of density of a substance is density is equal to the mass of the substance divided by the volume. And density is used as a physical constant, pretty much like other physical constants like melting points, boiling points, refractive indices, and so on. All right? So this question is asking for the mass. Gives you some information. It gives you the density of the metal, and it says that it's a cubic piece of metal, and it gives you the length of each edge, right? Now, if the question is asking for the mass, we have to rearrange this equation here. So that means that this rearrange will give you mass is equal to the density multiplied by the volume. So we're given the density already. The question is, at this stage, what is the volume? And there's a formula you should have learned in your math class or classes, or even in high school. There's a formula that you can use to calculate the volume of a cube. Can anybody tell me what that formula is? The volume of a cube.
width by height.
I'm sorry?
Length by width by height.
Length by width by height, right? But more specifically, when it comes to a cube, it will be simply be length cube because each side has the same length, right? So you're right. You're right in terms of the formula, but there's another way of expressing it, which is simpler, right? So therefore, this will be equal to density multiplied by the volume, which is equal to the length cube, right? So the density is 8.9 grams per cm cube multiplied by the length cube. What's the length? 5.25 centimeters, and all of that will be cubed, all right? And then you do your number crunching. And again, in this case, you're multiplying, so you have to round off your answer to the lowest number of sig figs. So let's see what this gives. So 8.9 multiplied by 5.25 cubed. Where's the cube side on this calculator? Okay, and then according to my calculation, and please correct me if I'm wrong, make sure you do the calculations as well so that if I make a mistake, you can point it out to me. But according to what I got here, the answer has to be rounded off to 2 sig figs. So that means that the answer, according to my calculation, is 1,300. And the units here would be grams. And the reason why the units will be grams is because this centimeter cube unit will cancel out that centimeter cube unit, right? And that's basically how that will be done. And please note, you'll notice that when I'm doing these calculations, I include the units as a part of the whole process, right? That's what I expect from you when you're answering these questions, right? Make sure you include the units because by doing that, you're going to see eventually how you end up with the final unit as a result of canceling out the units that should be canceled out, all right? Okay, any questions about this one? Any questions? Any questions? All right, so let me clear this and scroll down to the next question, which is dealing with a process of determining the density by submerging an object, the density of an object, by submerging it in a liquid. And I think in some textbooks they call it something like by the displacement method. So the question says, it gives you the density of a metal, and then it says, what is the mass of a metal when it is dropped in water, and it gives you the volume, 28.9 mils, and then the volume increases to 56.4 mils. So basically the whole concept behind this particular process is that you're trying to measure the volume of an object. And this is used mainly for determining the volume of an irregular shaped object, because for regular shaped objects, like a cube that we just looked at, or a cone or something like that, there are formulas you can use to calculate the volume of a regular shaped object. But for an irregular shaped object, you cannot use a formula. You'd have to use some method other than calculation, and that would be, in this case, the displacement method, right? And the whole concept behind the displacement method is that if you have a liquid in a container and it has a particular volume, right? And then you submerged the object in it, then what will happen is that the object will displace a volume which is equal to its own volume. So therefore, the volume that you're going to read, it could be in a measuring cylinder, for example, upon displacement will be greater than the initial volume before you add the object. The difference between those two numbers would give you the volume of the object, all right? So that's basically the whole idea behind this particular question. So let's see here. So the first thing I would do to solve this problem is I would find the volume of the object. And that would be equal to the difference between the 56.4 mils and the 28.9 mils. All right? So let's see here. 56.4 minus 28.9, and I got 27.5 mils. And then now to find the mass. So as we said before, mass is equal to the density multiplied by the volume, right? So in this case here, the density is 9.80 grams per mil multiplied by the volume that we just determined from earlier, which is 27.5 mils. So that would be 27.5 multiplied by 9.8. And in this case here, how many sig figs do we have here? We have 3 sig figs here, 3 sig figs here. So that means that the answer here would be 270, but I have to put a decimal point here. And everybody understands the reason why, right? Why do I have to put a decimal point here? Because? Because? Right, you have to show that the zero is significant. So the only way you can do that is by putting the decimal point right here, all right? And of course, the units, can't forget that, would be grams. All right, so that would be the final answer. Okay, any questions? Bless you. Any questions? Any questions? All right, man, I'm having so much fun, I didn't realize how fast time is going. Okay, I'm going to stop here for today. I was hoping to get to the next assignment, but unfortunately, that's not the case. What I'm going to do is, I'm going to leave number 9 for you to do. It's a bit more challenging than the others, but I think you guys should be able to do it. But again, if you have any issues doing it, let me know. What I'm going to do is, I'm going to set up a Dropbox for this assignment. Let me this. So I'm going to go to assignments. And then I'm going to publish that. And then I'm going to go here. And okay, so today is the 16th. I think you guys should be able to complete this assignment by Wednesday of next week. So I'm going to set a deadline as way past. What am I doing? Okay, so Wednesday the 21st at midnight is when it's going to be due. So make sure that, and I'm going to in the announcements later on today, I'm going to give some information as to how you should I think I told you before that you should submit it as a PDF document, but there are some other things I need to tell you about how to submit the assignment. So look out for that. Let me change this here as well. Okay, going back. Okay, so that's today. And then this will be the final date it's going to be available. Okay, what is it saying here about the account? Oh, I'm sorry. Okay, now we're in business. All right. So it's going to be available from today, the Dropbox that is going to be available from today until next Wednesday, and you have until that date to submit, all right? Okay, so that's it for today. If you have not signed the attendance sheet, please do so before you leave.
Are the signatures recorded?
Yes, in fact, I'm going to right now I'm going to post it in it's going to be located in the module section.
Okay,
All right.
awesome, thank you.
Yes, sir. Yeah, you need to submit it. But I think deadline date is passed. So what you should do is send it as an email. All right? Okay, so let me yes, ma'am.
Hi, I just want to ask if I could submit assignments in this format, like where I wrote it, or
Oh,
just
yeah,
type it
yeah.
out?
No problem.
All right.
No problem. Okay, so let me.
Thank you.
Yes, ma'am. Okay, for you guys out there in Zoom, I'll be signing off now.